and I will try to share the recordings after the meeting. So, Amir, floor is yours.
Okay, thank you, Dr. Kuhn. So, in next few slides, we want to talk about how to do non-adiabatic coupling without a spin, mostly in the WASP software and the Cori. So, to have, can you hear me?
At least I can.
Okay. Yeah, for non-adiabatic coupling, this is the process that we should go forward. First of all, we have the geometry of the system. We should do geometry optimization at the ground state. Then we need to copy the cont car file as a new postcar and start the heating calculation. At the end of the heating, we have again the cont car file. We should copy that cont car file again as a new postcar and do the molecular dynamic calculation at the desired temperature. So after this, we have all generated molecular dynamics files, and after this, we can start the coupling calculations. So always it's recommended to make a subdirectory, for instance, in molecular dynamic or somewhere else, and copy all those generated molecular dynamics file to start the coupling calculations. So there are totally 5 steps. In the step 5, we should extract atomic configuration at each time step from the outcar file of the molecular dynamic calculations. So to do this, there is this freshly revised PL file that is available in the bin directory, outcar to postcar. So just need to pay attention that you should check the postcar file to be consistent with the WASP version 4. And if you compare these two here, this CH atoms, for instance, label in line 6 should be deleted. So I face a lot of problem with this, but Dr. Kiri just commented on that. So usually by doing this comment, we will extract the postcar file or atomic configuration at each time step. For instance, we have totally 1000 time step. For each time step, we have the atomic configuration, the coordinates of the system. And this comment will generate 1000 files in the format of PXX, for instance, P00 or P99 for the...
Amir, may I interrupt for a second?
Yeah.
So for those who will be listening in the recordings or for those who are not visiting this meeting for the first time, can you just briefly remind what are the tables in the bottom? Like which molecule you try to describe and what these columns of numbers mean?
Yeah, so this is the...
We have an undergraduate summer student visiting and this brief, maybe 20-second.
Yeah, this is the totally configuration for a benzene molecule. So totally we have 6 carbon and 6 hydrogen. C stands for carbon and H hydrogen. Totally of 6 atoms for each of them. And the first 3 lines are the size of the simulation box or cell size of the model in the WASP calculation. And these 3 columns are the coordinate, actually normalized coordinate in the WASP format. So usually between 0 and 1. And yeah, is there anything else that I missed or everything is okay?
So your calculation would generate 1,000 of these documents?
Yes, for each time step, we have updated the actually coordinate, okay? This Perl file will extract those coordinates and save them in 1000 separate files. P000 to P999, for instance, for 100 time steps.
Thank you.
Yeah, for 1000 time steps, sorry. So now we have the actually atomic configuration. The next step would be generating the energy pop and input overlap. So to this end, for energy pop, we should choose the latest, actually the frontier orbitals near the band gap. For instance, here we choose orbital 10 to 21. This is for energy pop that you can see here, and also we need to make to generate an input underline overlap file needed for some VASP property calculation. There are three numbers here: 10, 21, and 1. 10 is the minimum number of the orbitals. 21 is the maximum number of the orbitals, and the third row or third number in this input overlap always should be 1.
Amir, may I ask you to make this general introduction and tell what are the first, third, and third columns in this table?
Sorry, sure. So the first column is the orbital number. For instance, from 10 to 21. You can see here, for instance, the HUMO is orbital number 15 and the LUMO is number 16. So these values are energy level of each orbital. And the third column is the occupancy of the orbitals. For instance, each occupied orbitals here occupied by 2 electrons, and unoccupied electron occupancy is 0. So that was the meaning of that 3 column in this energy pop file. So now we need to copy some files available for the coupling calculation. First one is the in-car for coupling that is available in bin directory. In the VASP actually package, we should copy that as an in-car file to start the calculation. Also, there is another directory, coupling is a subdirectory of bin, and in the coupling directory, there is another directory, no spin. So some files are available here that we need those files for the coupling calculation, which are listed here. And to start this simulations, we need the last 2 files to be run. So the Cori coupling.sh and bscipt.sh. So we can review that in the following slide. So
Amir, I apologize for interrupting, but to make it broad, can you add some general words about what is in-car file?
Yeah, in-car file is actually the input file that we use for the VASP calculations. We put all the settings about the simulation of the quantum mechanic modeling and DFT calculation of the VASP. All comments and settings, everything should be included in the in-car file. So this is maybe the most important input file for the DFT calculations.
Thank you.
Okay. So in the previous step, we copied the required file for the actually the required in-car file. So how to run that? First, we need a .sh submit file. We need to submit, for instance, dispatch Cori coupling.sh. If we take a look inside that file, we can see that the bscipt.sh file should be run inside this Cori.sh file. And yeah, this file load VASP to run the simulation, and also you can assign the number of nodes or wall time that you need to specify to run the calculations. And here we show the inside of that BSCIPT file required for the VASP calculation. Actually, by running this, we start to generate a coupling file for each electronic configuration that we calculated in step 1. For instance, we had P000 to P999. We had 1000 atomic configuration, and by running this, as time goes, we can check the directory. We can see that the couplings file are going to be generated. So there are several lines that we don't need to go in detail here, but you can see that in this file, it will run the VASP STD calculation, but the most important comment is here. For instance, 101 to 300. Totally, coupling calculations are time consuming, and we need, for instance, for this file, calculate 1000 coupling files. So it's not possible. Totally, we have 48 hours or 2 days maximum wall time. So it's always good to split the coupling calculation in the different range. For instance, go for time step 1 to 100, then 101 to 200, then 201 to 300. And by doing that, we can have the coupling file calculated for all atomic configuration. So this file always need to be modified for each time step range that you want to calculate the couplings. Here, just an example, for instance, for time step 101 to 300. And yeah, as we adjust that file, we can see that some coupling files will be generated in this format of naming, coupling 000 to 001 and 002. So after finishing this, for each PXX calculation, you should have a coupling XX the actually data file. And yeah, if you take a look sorry, at the directory of the coupling calculation, for instance, here you can see all the PXX atomic configuration file that are generated. This is the last second snapshot that I added. There is some problem. I needed to revise, but you can see that, for instance, coupling 410 is generated, and also some other files. And Dr. Killing, can you comment on this? What are those .gz files that are generated here? I'm not sure about them.
Yes, Amir. The coupling files need to be processed via as a next step on personal desktops or laptops with MATLAB software. So they need to be transferred from the cluster to the terminal. And GZ is a format of archived, squeezed, compressed files. So to shorten the file transfer time. So one can compress files on the server, transfer them to local computer, and then unzip to make them decompress and make them in the original format.
Okay, thank you very much. Yeah, as you can see, I performed the calculation until 500 time step, if I'm not wrong, for that benzene molecule. Next slide, you can see the first let's see the inside of the PXX file. You can see that each file includes just an updated postcard file at the desired time step. And this is the inside of the each coupling file. So it includes several columns of numbers, and I appreciate Dr. Kirina if contribute and put some comments. What are those numbers?
Thank you, Amir. I would happily answer, but there are more qualified attendees who can address it. So, what may I ask you? What is the dimension of this matrix?
I didn't check exactly.
But it looks like a square matrix. And how does it relate to the size of energy pop and content of your input overlap file?
So the size is
basically how many rows and how many columns?
If I'm not wrong, we should have equal to the number of orbitals that we specified in the energy pop file.
Mm-hmm. Can you scroll back to your energy pop?
Yeah.
Okay, so how many lines are here?
We have 11, 12.
Okay, so now let's go to the coupling file.
Mm-hmm.
Yep. So the lines are so long that it doesn't fit into the screen. Therefore, it continues line on the next actual row of the matrix is continued on the next line. But can you count how many numbers are in one row?
Sure. So it should be 12.
Okay.
Yeah.
And how many columns?
Oh, sorry, the 12 column.
Okay. So it is 12 by 12 matrix, right?
Yeah.
So what is on the main diagonal when number of row and number of column coincide? Look for the element 1, 1 on the very beginning of the matrix.
Yeah, they should be 0 diagonal.
Okay. Yep. Do you see the trend to continue? Like element 2, 2 in this big matrix?
Yeah, it should be 0 again.
Okay, which means that the probability for electron transferring from the orbital to itself is 0 because it's already there, right?
Mm-hmm.
And can you navigate your cursor to element 1, 2? Yep.
Yeah.
So what is the value?
0.11.
So it is non-zero probability,
no.
Which means it will be probability transfer for electron to go from orbital 10 to orbital 11.
Mm-hmm.
And all of these values are such amplitudes of probability.
Okay.
Can you give your own idea why do we need 1,000 of these files rather than only one?
So we need to do this probability calculation over the time because
like if you compare this coupling files, file number 1 and coupling file number 2, use the probabilities the same or different?
Should be different.
Okay, and then one needs to average over them.
Yes.
Okay, good. Is it the last slide or you have more?
No, that was the last one.
Okay, then please, I invite everyone to join me in thanking Amir for valuable presentation. So questions are very welcome to be asked in verbally, or you can type them in the chat line as a speaker is speaking. So, yes.
I have a question. I apologize if I missed it, but you said these are the probability of the location of the electron, or what were the values?
Transferring of the electron from one orbital to another orbital, if I'm not wrong.
Okay. So is that just 2 orbitals you've specified, or is it just kind of like random?
In the energy pop, we specified 12 orbital from, for instance, number 10 to here to 21, 12 orbital that we specified here.
So the probability it's so that's why it's 12 unit matrix, right? What, 12 possibilities of transfer then? From like 10 to any of the other ones?
Mid, I didn't hear you at the beginning. Can you repeat your question, please?
So is that why we had the 12 unit matrix in the last slide? Because there's 12 possibilities the electron could go somewhere?
Yes, no, each row, totally in that file, we had 12 row for different orbitals, and the 1 by 1 I by J or J by I represent the probability transferring between those orbitals. Please correct me, Dr. Kilin, if I'm wrong.
Sounds you're correct. And everyone is in the audience is welcome to correct if something is said wrong.
Thank you.
Yeah, welcome.
So more questions to Amir?
So I have, it's not actually a question, I'm just curious to know, right now I'm using like VASP6, why is still using the VASP4? Is there any specific reason for that?
No, Jabet, the format of the postcard only once is converted to VASP4, but all calculations can be done with more recent version of the code. And the script that converts outcar into multiple postcards was originally written many years ago, and it's just practicing laziness. So to keep old codes and not to rewrite them. So it's easier to correct one file of the data than to edit the script.
Thank you.
More questions to Amir? If no, please join me thanking him once again.
Thank you.
So, Amir,